Hello students, how are you? I welcome you all to your favorite channel. And today we are here to study the first chapter of physics, that is physical world. Well, what do you mean by physical world? Simply speaking, physical world is the world around us. Now, before riding on the roller coaster of physics, before we enjoy physics, there are many things to come in physics. So before going to ride on the roller coaster of physics, let us try to understand the origin of the word, the etymology of the word physics. It must be known to everybody. Physics comes from a word physis, a Greek word. And physis means nature. Nature means physical world. Before 15th century, in English, the word was physic. In Latin, it was physica. In Greek, it was, modified as physica. But finally, in the late 15th century, by the end of 15th century, finally, the word, the much awaited word came into existence, that is physics. So I hope you have understood the etymology, the origin of the word physics. And now the finally respectable word has come into existence, physics. So what physics is? What is the objective of physics? Well, quite clear. Physics is definitely, no doubt, is a science. Do you doubt about it? No, it is a science. Because science means, science comes from Latin word scientia. It has its own etymology, scientia, and scientia means to know. Why does it come back? We want to know. When I jump, why come down? We want to know. How is this camera taking the pics? We want to know. So, if you want to know, you are studying science. If you do not want to know anything, you are not a human being first. So, every human being has some interest in science. And physics is a part of science. Science has huge scope. So, physics is a systematic, not random. It has a proper strategy, proper system, systematic attempt and step-by-step attempt to understand natural phenomena, the processes, the activities, the events that are occurring in our nature are known as natural phenomena, earthquake, cyclone. So natural phenomena in as much detail and depth as possible. So the mission and the objective of physics is to understand the nature of which you are a part. And we want to understand the phenomena in full detail to the level that is possible. But why? What is the use of doing so much hard work? What is the use of thinking day and night, 24 hours? What is the use of just pondering over 24 into 7 into 365 or even till you die? Simply about the natural phenomena. What is the use? Well, quite simple. Whatever knowledge we gain, whatever concepts we develop, whatever facts we learn, whatever ideas we get, those knowledge will be used or is being used to predict the phenomena, to modify the phenomena, or to control the phenomena for the sake of humanity. Just suppose if earthquake would be predicted, however we are not able to predict earthquake, but researches are going on and physics is helping. So if we predict the earthquakes, how much beneficial it would be. Just imagine. So the motto of physics is quite noble, and you are here to study a very noble science. Now, well, students, of course, the mission of physics is to understand nature. But the question pops up in mind, is it possible to understand nature, or is it possible to understand universe completely? Its answer is yes and no as well. The answer is no for the common people who do not think, who do not want to take burden of thinking process. But answer is yes for a genius, for a man who just believes in thinking, who believes in working harder. All we need is an unflinching and consistent effort and deep thinking process. Here, I will quote Einstein. Once he said that the most incomprehensible thing, incomprehensible means something that cannot be understood. So the most incomprehensible thing about the universe is that it is comprehensible. Means if someone says universe can be comprehended, universe can be understood, even Einstein said that it can be understood, but it is very hard to believe. So Einstein was a supporter of the concept that yes, a natural phenomena, a natural process, the universe can be understood. And physics is all about understanding the nature. It is just a growing science. New and new concepts, new and new theories, and new and new laws are coming every day, almost every year, just in order to do the noble function of understanding the nature, the universe. But how is this done? What is the process of understanding nature? So there are two basic principles of physics, basic ideas of physics. Two. First is unification, and the second is reductionism. That unification and reductionism are the two basic principles propelling the physics. These are two basic principles of physics. Unification means to unite the things, to bring the things together. Listen, unification is an attempt to explain the entire physical phenomena. There are so many physical phenomena. Rotation of earth, revolution of moon around the earth, falling of something. All these phenomena, like sometimes comets come and they become invisible, and they again come after certain so many years, they again come back. Like Halley's comet comes after every 76 years. So once you see Halley's comet in your life, then it is damn sure that you are not going to see it again. So there are so many natural phenomena. The attempt that all the natural phenomena can be expressed by limited laws, by limited theories, then this attempt, this approach is called unification. Just look at this example. Earth is revolving around the sun. We know it well because of the gravitational force on earth by the sun. However, unfortunately, nowadays it is becoming very popular. Even a 6th class student knows that there is no any such force. But still it is applicable. The theories of Newton are still applicable. According to Einstein, there is a curvature in the universe, and because of that curvature, the things are falling in that. Whatever be the cause, nobody knows for sure. But yes, here earth is revolving because of the gravitational force on Earth by Sun. So here gravitational force between the two is responsible for the revolution of Earth. Now come on Earth. An apple falls down. Again here the reason is same, because of gravitational force on apple by the Earth. Two different phenomena are being explained by the same principle, the same theory. This is what we call unification. The second basic principle in physics is reductionism. Reductionism means to reduce the things. What does it mean? It is an attempt to explain a macroscopic system. You know, macroscopic means observable, the thing that we can observe. Suppose we can observe its color, its length, its temperature, its mass, its weight. So the things that can be observed, that is called macroscopic system, a big system. So an attempt to explain a macroscopic system in terms of microscopic units of the system. You must be knowing that everything is made up of smaller particles. Everything is made up of molecules. Molecules are made up of atoms. Atoms are made up of electrons, protons and neutrons. Protons and neutrons are made up of quarks. Even quarks can be supposed to be made up of gluons. Even gluons are supposed to be made up of strings. You must be aware of string theory. It was the talk of the school, talk of the students of science. String theory, the theory of everything. So please write in comment box if you are interested in knowing string theory, then I am ready to explain. But right now, the purpose to explain a phenomena, a macroscopic system, in terms of its constituent particles. We want to explain a phenomena in terms of the constituent particles. We want to go to the atomic, subatomic, nuclear level, and then we try to explain. If any phenomena is occurring, then we try to go into the depth and we try to find out the reason from the constituent particles. This approach is called reductionism. See an example. This is a stone or anything lying over here. One man touches and finds that, oh, it's too hot. Means its temperature is very high. Now the question rises, why the temperature is high? What are the things that are making the stone or this object hotter? Now our scientists have understood the phenomena. It has been found that the constituent particles are constantly in motion. They are having kinetic energy, and the kinetic energy of the particles is responsible for the temperature. The more the kinetic energy of the particles, the more will be the temperature. So where is the reduction? We have understood the temperature which we can observe by touching in terms of the kinetic energy of the constituent particles. This is called reductionism. So I hope you have understood the two natural phenomena, the two natural principles, the two basic principles underlying physics, unification and reductionism. And the attempt is going on to unify the things and to have reductionism. Now we are going to understand what are the main branches of physics. You cannot count the number of branches of physics. The scope of physics is too vast to understand really. But there are some major branches which we must know of. Basically, physics can be divided into two parts: classical physics and modern physics. Classical physics is the old physics that was developed by Newton, Galileo, Archimedes, Aristotle and others. But in 20th century, the main names are Einstein, Maxwell, Planck. They developed a quite different branch that is called modern physics. In classical physics, the branches are optics, the study of light. Just I am going to give you basic concept. Otherwise, we are going to study the full detail of optics in 12th class. Acoustics, study of sound. Acoustic management, how is the sound managed? Acoustic. Thermodynamics, study of heat. Mechanics, study of motion of the objects. Electromagnetism, the study of charges and moving charges. Electricity and magnetism, and many more branches are there. Now in modern physics, quantum physics and relativity, both are developed by Maxwell, Planck, Einstein, etc. Now, as far as length is concerned, in physics we study about nucleus or even smaller than nucleus. The range is 10 raised to the power minus 14 meter to the entire universe. We study about the universe also. We study about the distances between galaxies, and its range is 10 to the power 26 meters. See the difference. Minus 14 meter power is, and the highest power is 10 to the power 26 meters. See the scope of physics. Just feel it. Mass. The mass of electron or even smaller than electron like gluons. Even we are trying to find the mass of strings. However, the theory of string is a bit controversial. So the mass to the mass of a planet, a star, the entire universe, 10 to the power 55. Here also you can feel the range. Minus 30 to plus 55. 10 raised to the power. Time. Time to just cross an atomic scale. Time taken by light to just cross the atomic scale. That time is also has a lot of significance. Planck's time. You will study about Planck's time. And this is small time to the time taken by light to come from one galaxy to another. The time taken by light to come from Andromeda galaxy to our own galaxy, the Milky Way. The time taken by light to go from one end of the universe. However, the universe has no end. It is just expanding, expanding, and will be expanding. So, in this lecture, I want you to feel, to realize the vastness of the physics that you are going to study. So my dear students, in the next lecture, we'll study about the fundamental forces of nature, and that will be the end of the first chapter. Thank you students. Thanks for watching.